Hello my dear students, this is Akash SD and welcome to the ASD physics classes students. I hope so you all are doing really great. So student, in this video we are going to solve the question from the topic Ohm's law. Okay, and this is going to be the second part of the applications of Ohm's law. So here you can see the question is asked in a 2013, important for JEE. Masses of 3 wires of copper are in the ratio of 1:3:5 and their lengths are in the ratio of 5:3:1. The ratio of their electrical resistances is how much? Okay, so here they are asking in terms of length and mass resistance value. Okay, so first we can write here the mass ratio. So you can write here, students, for the 3 wires M1, M2, M3, how much it is given here? It is given here 1:3:5. You can see here. After that, what they are telling that here? Length ratio it is given here. See, L1:L2:L3. How much it is given here? See, 5:3:1. Is it? Now after that, we have to calculate here the resistance ratio. So you know very well the resistance of a wire is given by rho into L by A. Now, L is the length, A is the area of cross section. But remember that one thing is there. Here they are asking in terms of mass. So you know very well the density equal to mass by volume. That means we can write here, see, I can write here, see, the density equal to mass by volume. Is it? And here students you can write here volume means what is this? A into length. Now if the conductor is like this, see, the conductor is like this here. This is the basic. No? Area of cross section is A and length is L. That means volume how much here? A into L. So students, from here if I write here the area of cross section value, so what this will come here? It will come here M by L into D, where D is the density. This value I am going to replace here. So what this will become here? It will become here rho L and A value how much here? M by LD. So here M and here LD. So from here we can write here R equal to, kindly see very well, rho D L square by M. What is coming? Rho D L square by M. What is rho? Resistivity. What is D? Density. And for what is there? All the 3 wires are made of the copper. That means rho and D will be constant. That means we can write here, students, this R is directly proportional to L square by M. Okay, this basic you have to remember that. Is it? After that, we'll just solve here the question. So we can write here, students, see, R1:R2:R3. What this will become here? L1 square by M1. See here please. L1 square by M1 is to L2 square by M2 is to L3 square by M3. Okay. After that, L1 square by M1 means what we can write here? See, 5 square by 1. That means we can write here 25 by 1 is to L2 square by M2. That means we can write here 3 square by 3. That means we can write here, see, 9 by 3 is to L3 square by M3. That means here 1 square by 5. That means what is coming here, students? It is coming here 1 by 5. Is it? After that, what we are going to do here in this, even you can write here, see, the 3 3s are 9 here. Okay. So 25 is to 3 is to 1 by 5. Students, I will just multiply here into 5 now so that we can simplify this. So what we can write here? 25 into 5, 125, and 3 into 5, 15 is to 5 by 5 means 1. That means what is coming here? Kindly see, 125 is to 15 is to 1. That means which option is matching here? You can see very well the option D is matching. Is it? So kindly see very well, students, here. Here remember that R is the directly proportional to L square by M to solve this kind of question based upon the length and mass. Okay. Next one, kindly. JEE 2023 question. A rectangular parallelepiped is measured as 1 centimeter cross 1 centimeter cross 100 centimeter. Okay. If its specific resistance is 3 into 10 power minus 7 ohm meter, then the resistance between its opposite rectangular faces will be how much? Again, I am telling which faces, students? Rectangular faces. So rectangular face means what will happen at here? If I write here, please, like this, let's check here. Now, at least for the basic. What we can tell you, students, here? Rectangular means, let's take here, this is the 100 centimeter and this is the 1 centimeter. Okay, then only it will become rectangular. Is it? After that, if I write here the other faces, let's take here like this. No, just for the basic understanding we are doing. Is it? So here like this is there. No, like this. Kindly see here very well. Is it? It is students here. So just like a parallelepiped is there. So you know this is 100, this is 1, that means this one how much will be there? See here please here, because 1 cross 100. This is 100, this is 1, that means what is this students here? This is the 1 centimeter, is it? And we can tell very well, see this is the area of cross section, and students this is also area of cross section, and we have to calculate the resistance between these ends, A and this end B, is it? So if I'll write here the students, the length how much is there? Kindly see here, 1 centimeter, that means 10 to the power minus 2 meter, is it? After that, if I write here the area of cross section how much is there? 100 into 1, that means 100 centimeter square, or we can write here, see 100 into 10 to the power minus 4 meter square, or we can write here 10 to the power minus 2 meter square. I hope so, this is very clear, is it? Now after that, if I write here the resistance, so resistance is given by, say, rho L by A, is it? Rho value what is given here, see, 3 into 10 power minus 7, is it? So see here, 3 into 10 power minus 7. Length how much is given here, see, 10 to the power minus 2, by area of cross section, how much coming here, see, it is coming here students here, see, 10 to power minus 2. So what will happen at students, you can see very well, this one and this one is going to cancel, is it? That means it is coming here 3 into 10 power minus 7 ohm. Now, and you can see very well, we have to fill which data is there. So here you can see very well, this is the 3, that means here we have to fill here 3. Is it, students? So kindly see very well, here we have to see the area of cross section rectangular, based upon that only we have to decide that. Okay, next one, see, next question, is it? NEET 2023, a circuit wire A has resistance 81 ohm. The resistance of another wire B of same material and equal length but of diameter thrice the diameter of A will be how much here? Now see, thrice the diameter of A. So we'll write down here first the data. What is given here? See the data. Wire A has resistance 81 ohm. So see here, RA is given 81 ohm. Okay. Material is same. That means what will happen, dear students? This rho is the constant, no, because the material is same, is it? Next one, what is given here? Length is also same. That means we can write here L is the constant. No, L is the constant, is the equal length, but of diameter thrice the diameter of A. That means what we can tell here, the diameter of B, the diameter of B is how much is there? Thrice the diameter of A. That means we can write here 3 into dA. So in the question students, they are asking here the resistance of the wire B. Now this thing we have to decide, then only we can solve the question, is it? This is the question situation. Now what we'll do here, remember that here, this resistance R is given by rho L by A, is it? See here, how I'm doing here, rho L, and area means what? Pi R square. If I write in terms of diameter, it will become here pi D square by 4. Now because R equal to D by 2. So students, from here I can write here, this R is directly proportional to rho is constant, L is constant, pi by 4 is constant. That means what we can tell here, inversely proportional to D square, is it? That's it, question completed. Now see, this is the situation. Hence we can write here, students, here, hence we can write here, this RB by RA is equal to what we can write here, this will become here dA by dB whole square. Okay, and what is the dA by dB? If you see from here, dA by dB will become here, students, 1 by 3, is it? So we can write here 1 by 3 square. Okay, that means this RB is given by RA by how much? 9. Okay, RA value how much is given here? 81. So students, if I will write here 81 by 9, it will come here, how much is there? 9 ohm. Okay, that means any option is there 9 ohm. You can see very well, option B is the correct answer, students, and here the answer is the how much? 9 ohm. Is it? Great. See how much beautiful way we are solving these questions, how much easy, is it? So see, now JEE 2023 question is there, see, a wire of resistance 160 ohm is melted and drawn into a wire of 1/4 of its length. The new resistance of the wire will be how much is there? Okay, so again see here, let me write here, the resistance how much is given is there? 160 ohm. The resistance is the 160 ohm. Now first have to note down the data, and drawn into a wire of 1/4 of its length. New wire will have length how much here? 1/4. That means L2 equal to how much is there? L1 by 4 here, 1/4 of its length. Okay. The new resistance how much they are asking here? The new resistance R2 how much here? Okay. So remember that here whenever the wire is going to melt, now when the wire is going to melt, the volume is not going to change. Volume will be same. So what I will tell you here? The new wire means A2 L2. Old wire A1 L1 that will be equal. A2 L2 equal to how much is there, students, here? A1 L1. So from here, students, if I will write here the what is the value of A1 by A2? A1 by A2 I can write here L2 by L1. Is it? And you can see from here L2 by L1 how much, students, here? 1 by 4. Is it? So now this data is ready. After that we have to write here the values. We know R equal to rho L by A. Rho is constant, is it? So we can write here R directly proportional to L by A. Now always see. So we can write here R2 by R1 is equal to L2 by L1 directly proportional. A inversely proportional means what you write here? A1 by A2, is it? Now kindly put here the values, please. So we can write here, see, R2 by R1 value how much is there? 160, is it? Is equal to L2 by L1 how much is there? We know very well 1 by 4. 1 by 4. And A1 by A2 value how much? Again you can see here 1 by 4. That means we can write here this R2 is given by here 160 by 16. So 160 by 16, when you will simplify this, it will come here the 10 ohm. Is it? So any option is there 10 ohm, students, here? Kindly see here. Option C is the correct answer, is it? So whenever the wire is going to melt, the volume is going to be same, A2 L2 equal to A1 L1. Is it? Great. Next one, students, you can see here this question. Here the question is, see, a uniform metallic wire carries a current of 2 ampere. When 3.4 volt battery is connected across it, the mass of the uniform metallic wire is this one, 8.92 into 10 power minus 3 kg. Density is the this one, 8.92 into 10 power minus 3 kg per meter cube. And resistivity how much is given here? 1.7 into 10 power minus 8 ohm meter. Okay, students. So what is the length of the wire? Okay. So here we have to calculate here the length, students. Is it? So first let me write here the values here, students. If I write here the resistance, no? So resistance is given here. What is here? V by I. V by I will be what? Students, kindly see here. The V is the 3.4. Okay. This is the 3.4 and I how much is there? 2. Data is too much, so we have to be careful. So it will come here how much is there? 1.7 ohm. Okay. After that, let me write here the values, please. Now other values are there. No, so many values are there. The mass of the wire is given here. What? The mass is given here 8.92 into 10 power minus 3 kg. Okay. And the density is given here. Even this is also, I think so in this question the density is the somewhat different, but okay, I will write here the density. Let's take it is given here how much here? Again, students, 8.92 into 10 power minus 3 kg per meter cube. After that, resistivity what is given here? The resistivity is given here, see, 1.7 into 10 power minus 8 ohm meter. Okay, so we can see here, students, see. Now the question, how to do the question here? See here, R equal to rho L by A. Correct? R equal to rho L by A. Mass and density is given, students. Okay, that means we can write in terms of volume even. So can I write here L square by AL? Any problem? No problem. Is it? So students, we can write here, see, the rho into L square by volume. Is it? And we know very well rho L square. You know here, students, you know very well the density equal to mass by volume. Correct? Na? Density equal to mass by volume. So what is the volume? Volume is given by, students, mass by density. I will write here mass by density. So D will come here. Is it? So if I will write here, students, this you can see here L square. Now L square is equal to what will become here? M into R. Can you see very well? M into R by rho D. M into R by how much here? Rho D. Okay. After that, kindly see here, if in case, students, if I will remove this square. Now, so when I will remove this square, what will become here? It will become here the square root. See, this is the formula. This is the main formula. After that, we have to just put here the data and all that, and the answer will come here. Okay. So kindly see here. Here what is given here, students, see, the mass is this one, see, M by rho. See here first, this M by D. I think so here little bit data problem is there. I will just check it out, but kindly see here. M by D is there, R value. Let me put here the first R value. R is the 1.7. I am putting here the value of R, 1.7. And the rho value, how much is given here? See, 1.7 into 10 power minus 8. I am just putting here the values, students, here. Now, this is the which value? R value. This is the which value? Rho value. M by D I am stopping because little bit data problem is there, that only I have to check it out actually here. Okay. So what is the M? M is given here, students, 8.92 into 10 power minus 3. 8.92 will cancel out when you will put the value here. Okay. So what will become here? See, this is the 10 power minus 3, and what is coming here? Here it is given 10 power minus 3. Okay. So actually, students, in this question answer should come 10 meter. Okay, answer is the 10 meter. So just let me just put here the data actually. So students, here the data, if I will see here, just 1 minute, minus 8 will go up. No, this minus 8 will go up. So 10 to the power 8, and here it will come, students, 10 to the power minus 6 actually. Okay, how the minus 6 will come here? If in case instead of minus 6 we want, no? minus 6 we want. Okay, so minus 6, what will happen here, student? This should be minus 9. No? See here, just let me put here minus 9. Now little bit the typing mistake happened. So what will happen here? It will become here 10 to the power 3 will go up. It will become here minus 6, and what this will come here? It will come 10 power 2, and the length will come here what? Square root of 10 power 2. How much is, students, here? It will come here the 10 meter. Okay, the correct answer is here what? Option B, because when I was reading the question, I understood something went wrong. Okay, so what is coming? This M is there, now minus 9 is there, this one. This should be minus 9. Okay, this one, can you see it? This is the minus 9, and here also, where is the mass is there? This should be minus 9. Okay, minus 9 should be there, then only it will match and the answer will come. Can you see very well, students? Okay, the mass was little bit problem, that's why the answer was not matching. Is it? Great, great, great. No? Next one, kindly see, students, this is the question, no? Easy question. See here, see. The resistance of platinum wire at 0 degrees Celsius is how much here? 2 ohm, okay, and 6.8 ohm at 80 degrees Celsius. The temperature coefficient of resistance of the wire is how much? Okay, so let me write here, students. If I write here the value, see, this R naught is given here, how much is there? 2 ohm. 2 ohm, and the temperature T naught is given here, how much here? 0 degrees Celsius. After that, the next resistance, students, this RT is given here 6.8 ohm, okay, and the temperature is given here, how much here? See here, students, 80 degrees Celsius, is it? And you know very well which formula we have to use it to get the value of the alpha. Remember that here, students, the standard formula is there, RT equal to R naught 1 plus alpha T minus 0 means T. Okay, so if I will just simplify this here, what will become here? RT by R naught. RT by R naught, how much here? 6.8 by 2, that means it will become here 3.4 is equal to 1 plus alpha T, is it? So if I will write here the value of alpha, so 3.4 minus 1, 2.4 divided by T, and what is the value of the T, students? This is the 80, no need to convert into Kelvin. Okay, so students, when you will simplify, this is there. Okay, after simplification and all, students, it will come here very easily, 3 into 10 power minus 2 degrees Celsius inverse. Na? Just simplify this. Which option is there? Option B is the correct answer. Is it, students? You have to just simplify this, that's it. Very easy, very easy, very easy. Okay. Now, students, if in case the temperature is not 0 degree included, then how to do the question? See, this question, JEE 2021, see. The resistance of a conductor at 15 degrees Celsius is 16 ohm, and at 100 degrees Celsius is the 20 ohm. What will be the temperature coefficient of resistance of the conductor? Here 0 degrees Celsius is not involved. Okay, so first let me write here the data. Initially, what is given here, students? I will write here the RT1. Okay, RT1, I will write here how much is there? 16 ohm, and how much temperature? T1 equal to minus 15 degrees Celsius. Okay, after that, see the next one, the new resistance, what is there? See here, RT2, how much is given, students? See the 20 ohm. Okay, and this T2 value, how much is given here? 100 degrees Celsius. What they are asking? They are asking the value of the alpha. Okay, so when this kind of situation is coming, there is the two ways are there to solve this question. First, I am going to do here the method 1. So for method 1, what will happen? That here, write down like this here, RT2 is equal to RT1 1 plus alpha T2 minus T1. Okay, this formula you have to use it to get the answer. So when I will just put the values and all here, please, what will happen that here? RT2 by RT1, that means it will become here, students, 20 by 16, correct na? 20 by 16. So 20 by 16, what will become here? 4 5 ja 20, 4 4 ja 16 na? 20 by 16 means 5 by 4 is equal to 1 plus alpha. Delta T, how much? T2 minus T1, see from here. 100 minus 15, that means it will become here the 85. Okay. So when I will simplify this here, it will come here 85 alpha is equal to 5 by 4 minus 1. 5 by 4 minus means it will become here 1 by 4. Correct? Then after that, I will write here the alpha. Alpha will come here 4 into 85. What is coming, students? 4 into 85. And can you simplify this? It will come here 4 5 ja 20 and 4 8 ja 24 plus 2 26. Correct? 1 by 260. So when you will solve here, this alpha value is going to come here. When you will simplify this, it will come 0.003 degrees Celsius inverse. Now, just simplify this, answer will come. Answer is the option C. But remember that here, this formula is valid for the limited range of temperature. If in case the answer is not matching with this, we have to go with the second one. What is the second way is there? The second way, students, is there. We have to do like this. RT2 by RT1 is equal to C. R0 1 plus alpha T2 by R0 1 plus alpha T1 by the division method. Okay, with respect to 0 degrees Celsius we are going to write. Okay, so what will happen that here, when you will put the value is there, RT2 by RT1, how much? Again 20 by 16 means, students, here 5 by 4. Okay, and here 1 plus T2 value, T2 100. So we can write here 1 plus 100 alpha by 1 plus T1 value, how much is there? 15. Okay, so 1 plus this one, 15 alpha. So again, when you will simplify this here, in this situation, again the value will come same, 0.003 degrees Celsius inverse. But students, if you have to choose between method 1 and method 2, I will tell you the maximum to maximum, you go with this method. Okay, because this is the very good method and that follows that temperature range. Okay, can you see very well? Because actually this is defined for the exponential function, but we are considering it as a linear function. That's why this one, second method, is best. After that, students, here, this is the question is there, son, JEE 2024. Important, kindly see very well. An electric toaster has resistance of 60 ohm at room temperature 27 degrees Celsius. Now see, the toaster is connected to a 220 volt supply. If the current flowing through it reaches 2.75 ampere, okay, the temperature attained by the toaster is around how much? Okay, the temperature attained by the toaster, how much? Okay, so students, let me see here, please. First one, see. Now start with the decoding. Initial temperature, how much is given here? See, 27 degrees Celsius. Okay, because I have to also think, is it? It does not mean I remember that. After that, the resistance, how much is given here? See, it is given here, students. RT1 is given here, how much here? 60 ohm. Okay. After that, see, the toaster is connected to 220 volt supply and how much current is there? 2.75 ampere. Okay. So if I will write here the value of the RT2 here, see, this RT2 will come here 220 by 2.75. Okay. 220 by 2.75. Now you have to simplify this, and then at this, what is the temperature? Okay. So students, again I will just tell you here the basics. The basic is what? Again we'll use this formula, see, RT2 by RT1. Okay, RT2 by RT1 is equal to, again see here, 1 plus alpha T2 minus T1. Okay, T2 minus, RT2 equal to RT1, 1 plus alpha T2 minus T1. After that, students, what will happen that here? Kindly see here very well. RT2 how much? This one, see here, 220 by, you have to simplify this, just 2.75 into RT1 value is the 60, okay, is equal to, here please, 1 plus alpha T2, new temperature we don't know, okay, so let's write here the T2 minus T1, how much is given here? 27, okay. So in this equation you can see very well all these things are given. You have to just simplify this, alpha value is also given here, na? See, this is alpha value, na? You have to just do the calculation and all. And when you will do the calculation, students, this T2 value, it will come for you, this one here, 1694 degrees Celsius. Now, you just have to do the calculation. I have done the calculation. I have got it. That's why I'm telling you. Okay, how much coming here? 1694 degrees Celsius. Okay, 1694 degrees Celsius. Kindly see very well. First, we have got the initial resistance 60 ohm, then the new resistance for the 2.75 ampere current here, okay, and then we have got here the answer. So students, I hope so this application of the Ohm's law you understood very well. Keep studying, keep growing.